Pulse code modulation and coding and decoding. The information is before we have to transmitting by using these techniques. First we have to sampling the according to sampling theorem. First convert analog signal into continuous signal into discrete them. That continuous signal can be discreted them by using the sampling theorem. Sampling theorem is to maintain the condition is sampling rate must be greater than twice of the maximum highest frequency 2 into greater than or equal to 2 times of fm in PCM digital schemes for transmitting of analog signal in PCM signals or in the binary form of the sampled voltages of electrical signal is converted into binary form. That binary form is converted into a digital data ones and zeros that can be converted into a ones and zeros. The data when we converted into a binary signal ones and zeros, whole signal of electrical signal of information is converted into binary by using the coded form by using this PCM. The PCM pulse code modulation pulse code modulation pulse code modulation PCM is goes to PCM pulse code modulation. Basically the PCM is transmitting the signals only two possible states, logic 1 and logic 0. One is represents logic 1 and one is is logic 1 is a high bit. Two possible states of the signal is converting from high and low, means bits are 1 and zeros. Using in PCM it is possible to digitize all the form of digitized signal, all the form of analog data including full motion of this can converted the information is motion of the video signal and also transmitting the information in the form of voices and also sharing the information in the form of music and also telemetry system and virtual reality. These all are the various techniques are implemented by using the converting of analog signal into digital by PCM techniques. That the videos or images, voices, signal can be modulated with this pulse code modulation. After converting the bits, it is a stream of pulses and non-stream of bits, stream of pulses and non-stream of ones and zeros, non-stream of pulses and zeros, ones and zeros, not easily affected by interfaces and noises, not easily affected by this transmitting of the binary data, not easily affected by interference and noise in the PCM. Even in the presence of noises or non-presence of the noises can be easily determined. In this PCM you can detecting the noises, non-noise signals. Since in PCM is a digital more general vision could be that the digital signals are easy to process by cheap standard techniques. It is implemented in communication by using the telephone networks. A network means two or more systems are interconnected to sharing the information. That information converted into digital by using the PCM technique. Basically, the PCM blocks are consisting the blocks of PCM consisting the blocks of source and sampling, and next stage, first stage is goes to the source, and second stage is goes to the sampling, third stage is goes to the quantization, next stage is encoding, and next stage is goes to the channel, and after that we have to decode the signal and reconstruct the filter signals and reaches the destination. And then to obtain PCM from analog signal at the source end of communication circuit. The analog signals amplitude are sampled at regular time intervals. Transmitting the analog signal amplitude is sampled. All the sampled voltage are regular in time intervals. To convert this digital according to the instantaneous voltage or current. Sampling rate or number of samples per second. Sampling rate is how many signals are transmitted per second whole data. Is the several times of maximum frequency of the analog waveform in cycles per second. And various blocks of these sources. First source is input signal. Next level is quantization, and the whole signal is represent the bandwidth of that particular signal. In binary PCM, you have group of bits. In binary PCM, we have group of bits and corresponding to the number of levels with n bits. If number of levels is dependent on the n bits, that is number of levels is equal to the power of n to the power of n, 2 to the power of n power of 2 number of bits. The message signal m of t is band limited to the bandwidth and which requires 2b samples per second, for 2b elements or information we must transfer 2n bits per second. Thus the minimum bandwidth bt total bandwidth is needed tv is equal to n into v. Total bandwidth is equal to samples per second. 2b elements information is transfer to nb. N is the number of bits, b is the bandwidth of the signal. The minimum bandwidth is needed. bt is equal to total bandwidth of the signal is to be transmitted 2 into n into b total bandwidth. Then after that we have sampling. Next stage is goes to this quantized levels. We have the number of quantized levels. If it is n bit data, 2 to the power of n, 8 is equal to 56 levels. If 2 bit is equal to there, 2 to the power of n, 2 to the power of n is equal to 4 bits. 4 bits. Instantaneous amplitude of the analog signal is sampled round of the nearest several round of signal to the nearest several specific predominant levels. 2 to the power of 2 means if it is 2 bits, 2 to the power of 2 into 4 levels. If it is 3 bits, 8 levels. According to quantization is the sampled voltages. According to the sampled voltages, sampling voltage is sampled. The number of bits, number of levels is always 2 to the power of n. For example of 8 bit and 16 bit, 32 bits, 64 bits. The numbers can be represented by the 5 bits, 4 binary digits, 5, 4, 6. Number of bits 8 bit, 16, 32 bits and 64 bits. The number can be represented by 5, 4, 6 binary digits respectively. The output of the pulses code modulator in this series of binary numbers is represented by some power of 2. The basically block diagram consisting of as shown in figure, and that first one is equal to source, sampling, quantization. After quantized levels converted into binary into encoded. That is equal to binary pulses code if it is a decimal number and the corresponding voltage 0. The binary voltage 000, 1 is equal to 001, 2 is equal to 0010, 3 is equal to 0011, 4 is equal to binary 4 is equal to. According to their binary decimal number is converted into a binary signals. Basically the block diagram consisting of a voltage levels is encoded the signal. Encoded is encoder is corresponding the digital of binary data, and the whole data is converted into a group of bits encoded, and here the data will be encoded the signal in the coded form. That's why it is a pulse code modulation. After coded signal is given to the channel. After channel is to a physical quantities like physical quantities, that is equal to channel. Physical is equal to channel is equal to channel is number binary data is transmitting into a channel. Channel is the whole signal 1 and zeros we are transmitting the channel. The noises will be occur. This is a physical cable to connecting between the transmitting and receiving end through the cable. That is the channel. More noises will be added. That can be noises will be reduced. Due to the noises, signal will be reduced. Can improve this signal by using the repeaters. Repeaters is every 10 kilometers we have the repeaters are used. What is the need for repeater is improving the signal strength, improving the binary data, improving the signal bit, improving the signal bit, that is improving the channel, improve the number of bit levels, improving the signal, improve repeaters to voltage levels are voltage levels are